Now that you've learned negative exponents and the zero exponent, we're going to move on to the properties of exponents that involve multiplication. So after the warm-up with a little bit of pattern recognition, hopefully you will discover and then be able to apply the multiplication properties for the exponents. So your warm-up, guys, says using repeated multiplication, simplify the following expressions so that each expression only involves one base with one exponent. So take a moment to simplify this, and I want you to write it out. Use that idea that, this is repeated multiplication when you use a power. So pause the video, write it out, see if you can write it with one base and one exponent, and then see if you can discover the rule. So when I write this out, I'm going to have 2 times 2 for the 2 squared, and then I'm going to have times 2 times 2 times 2 for the 2 cubed. All together, guys, how else can we write this? We can write this as 2 to the 5th. On the second one, we write it out. We have 3 times 3 times 3 times 3 for the first base. Then we have times 3 again for the second base. Then we have times a 3 times 3 for the third base. And I'm talking about each base here. All right, so all together, how else do we write this? 3 to the 7th. So what's the rule? What do you notice between what you started with and what you're ending with? Does the base change? Hopefully you're saying no. What happens to the exponents though? What do I do with what I started to get the end answer? Well, when you multiply the same bases, you add the exponents. And here's an example for you. So if I would have x to the 4th times x to the 5th, that would really be the same as x to the 9th. This is called a product of powers because you are multiplying. That's what product means. Multiplying something with powers. When you multiply the same base with powers, you can add their exponents. So let's do a couple examples for this one. Simplify each expression fully. So remember what we learned about negative exponents, and now use your new rule, including that. So if we had x to the negative 3rd times x to the 6th, I do want you to take the 30 seconds to show me negative 3 plus 6 is what I'd be doing here. Not even 30 seconds, guys, just 2. Show me that you'd be adding the exponents, so what do you get? You get x cubed. On B, we're multiplying all of these, right? This is a to the 5th times b to the 6th times a to the 3rd. We want to simplify it down so that it's as simplified as it possibly can be. And we will talk about what your answer should look like when it's fully simplified more tomorrow in class. But what can we combine? Well, we have the a then. That's going to be 5 plus 3 because there's 2 a's. And we're multiplying those. And that's going to be multiplied by b to the 6th. Are these the same bases? Can we add all of these exponents together? No. You can only add the exponents of the same base. So we're going to be left with a to the 8th, b to the 6th. That's more simplified, though, than what we started with, right? Because we had to write a twice. Now we only had to write it once. Last example, guys, you try it. Remember, if there's no exponent written, what is right there? So 1. So I'd have c to the negative 4 plus negative 3 plus 1. That's going to give me c to the negative 6th. Am I done there? Can I leave that? Hopefully you're saying no way. We got to put that under a 1 and make it a positive exponent. Okay? That's the product of powers rule. We're going to learn 2 other ones, and then it'll be more complex when we combine them all together. Back to that idea of repeated multiplication, okay? How would we rewrite this to expand it out? And let's see if we notice another rule. Notice that this is different than what we started with in the last one. The last one we had the same base being multiplied by another base that was the same. Here we have a power that's inside another power. So write it out. If 2 cubed is being squared, it's like we have 2 cubed times 2 cubed, right? You're squaring it, so you're writing that out twice. Well, we know how to do this because of the rule we just learned. How would you guys do that? You would keep the base, and you would add the exponents. So what do you get here? 2 to the 6th. Write out the next one for me, too. X to the 5th raised to the 4th power. That means we would have x to the 5th 4 times, right? Again, now we are multiplying the same bases. So what do we do when you're multiplying the same base? You add their exponents. So what's your new exponent going to be? X to the 20th. Now I want you to think if there's a shortcut. Could we just figure out, again, a pattern between what I did with what I started with to get my end result? That way I don't have to do this whole in-between step anymore. Do you notice something from here to here? And does it work from here to here? I want you to pause the video until you see it yourself. So what happens now when you raise a power to a power? Hopefully you guessed it. You're going to multiply the exponents and you're going to keep the base the same. So the base does not change. The base does not get squared. It didn't become 4 or anything like that. You keep the base. But all you have to do now is multiply the exponents. 3 times 2 would give me the 6 directly. 5 times 4 would give me the 20 directly. So fill in the rule and the example. If you need to pause the video, go ahead. So now let's try a couple examples here. If we want to simplify fully, we now know the rule. We don't have to go through the expansion. We can just do the shortcut. We have a power inside another power. So what are we going to do? We're going to multiply the exponents. Keep the base, and you'd have 3 times 5. Yes, I want to see this step, guys. This is your one line of work. Come on. So we get x to the 15th. Same thing here. We have a base with an exponent inside another exponent. It's a power of a power, so we keep the base, and you multiply their exponents. That would give me 4 to the negative 6. Do I leave that like that? No. Let's simplify it farther. 1 over 4 to the 6th. If you wanted, then you could evaluate it. It just says to simplify, so that's far enough for me. And the third example, try this one. So power inside another power, we would have b to the 2 times 3 times b to the negative 3rd times 4. I would like you to write this work. It's not a lot. These are your notes. That way you can go back and study it. Once we get into more complex examples in your homework, I will let you do more of it in your head. But please, guys, this is your notes. So write it out so if you ever forget, you can go back. So b2 times 3 would be b to the 6th. And then negative 3 times 4 would be b to the negative 12. Are we done? No way. We know this rule. This is the first one we learned. Multiplying the same base. What do I do with their exponents? Hopefully you're saying add, so we 6 plus the negative 12. That would give me b to the negative 6. Now I'm done, right? Hopefully, again, you are telling me no. It's going to be 1 over b to the 6th. Negative exponent, we can't leave a negative exponent in our answer, so I move it below 1. Last rule then, guys. It's called the power of a product property. When a product of bases, product, that means multiplication. So product of bases, that means multiplication, is raised to a power. Each individual base is raised to that power. So if you have inside parentheses a product, just one term, okay, but there may be more than one base, and they're only being multiplied, you can basically kind of like give each one of those the exponent. I'm going to stay away from that word distribute because that's going to throw you off. But you can give each base that power. You really might want to mark this down. This is only if there's one term inside. Only if there's one term inside. So if there's a plus or a minus, think about this. 2x plus 1. How many terms is that? That's 2 terms. If that was inside with an exponent, you could not give each base it. But if I have 3x, that is just one term. Multiplication can occur within a term, but as soon as you hit a plus or minus sign, it is more than one term. Okay, so only if one term is inside. And I'm going to give you a tricky one tomorrow to see if you remember me saying that. So mark this down. Okay, so your example 3, guys, fill them in and try these ones. Notice these ones have a lot more going on now because now we have 3 rules we've learned, so 3 rules we can apply. Let's do this first one together. So the negatives on the outside, I would just leave that hanging out then on the outside. What does this mean? Well, we have one term inside. There's only multiplication, so it's a product. We can give this exponent to each of those bases. So I'd have 2 cubed times x cubed. Let's keep going, keep evaluating. What is 2 cubed? It's negative. We have the negative on the outside. That's why it's negative. 2 times 2 times 2, negative 8 x cubed. Okay, let's try B. So B now, we have the power of the product rule as well as the power of a power occurring. This 4 is going to go to each base. What do you do when there's a base with a power and a power on the outside? Power of a power rule. Flip back if you need to. You multiply. So show me the little bit of work. We're going to have a to the 3 times 4 and then b to the 2 times 4. Simplify that down then. A to the 12th, b to the 8th. And last one, guys. I want you to pause the video and try this one. Okay, so pause it, try it, then I'll work it out for you. So we're going to distribute this, and we would have c to the negative 4 times 2, d to the negative 3 times 2. There's still this times another term. We would have c, again, give that exponent to each of the inside bases, 0 times negative 2, d 5 times negative 2. Whew. Let's do some of that multiplication. C to the negative 8th, d to the negative 6th, c to the 0. Do I need that? No. If you took it out already, hey, way to go. That's great. And then d to the negative 10th. Anything else I can do here? Is there another step? Absolutely. Keep going then. We have the c to the negative 8th, d to the negative 6 plus a negative 10. Multiplying the same base, you add these exponents. So I would have c to the negative 8th times d to the negative 16th. One final step then, hopefully you did not stop here. We are never going to leave negative exponents in your answer. Get used to it. I keep saying it. You're going to keep hearing me say it because that is not considered simplified. So you would put this under 1 and make the exponents positive to finish it off. You got that right? That's awesome. Way to go. You're on to your next task, guys. Keep working hard.